Hello, and welcome to another daily Leetcode challenge. Let's start question 33, search and rotated sorted array. So, there is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k such as bigger than or equal to 1 and less than num's length, such that the resulting array, 0 indexed for example, might be rotated at a pivot of 3 and become, an array of 0, 1, 2, 3, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 3, rotated at 3. Rotated at 3. That means, okay, I see. Given the array nums, after the possible rotation of an integer target, return the index of the target if it is return the index of target if it's a nums, or -1 if it's not a nums. You must write the algorithm in O log n runtime complexity. Okay, so again, pretty much a giveaway that they want us to use binary search. However, binary search requires an array to be sorted, and our array is almost sorted. It's additionally also rotated. So if I could actually find the pivot, and then do the search again, knowing that pivot, I could theoretically find the index of the target in 2 times log of n. But since log of n doesn't care about constants, and time complexity in general doesn't care about constants, we could go about it that way. So let's figure out how to find the pivot. My understanding of this is that if I'm doing the regular binary search, I have 3 values at my disposal. Usually I have low, I have mid, and I have high. Low, mid, and high. And in a rotated array, you are at your pivot is within low and high in the case that low is greater than high, if that makes sense. So if at any point low value is greater than high value, we know that the pivot must be between that range, between those 2 numbers. And so I'm wondering if I could use the middle value, so for example 4, 2, and 7, to figure out basically where this pivot is. So let's say that I'm at the first iteration of binary search to find the pivot. I have my 3 values, 4, 7, and 2, and I see that there is a pivot somewhere in between. Pivot is not 0, meaning that the array is not completely sorted. And now I do a check. Is my mid value greater than, let's say 2, or the first value? If it is, I know that the left portion is sorted and the pivot must be in the right. And so then I eliminate the left section and I move to finding the pivot in the right section. And that's it. I think that pretty much solves us having to find the pivot. That seems like a good algorithm. And then once we find the pivot, the rest is pretty easy. The rest is we set low and high to these values, to pivot and 7. And then since since Python has this cool thing where you can essentially pretend that an array is ongoing, like this. Let's see. This is what I'm trying to get at. You can essentially pretend that you start here and end here. And the way that you would do that is you can start low at 0, 1, 2, 3, 4, and you can set high at 4, 5, 6, 7, 8, 9, 10, and then do low and high module length of array, which is for us, I believe, 0, 1, 2, 3, 0, 1, 3, 4, 5, 6. And you would essentially get these values. Okay, so that aside, let's begin the implementation. So let's see, are there any conditions? There's some weird situations. If len, let's define if len, if L is equal to 1, if L is equal to 1, that's the condition or the constraint that allows us to, that makes the nums of length 1. Return, and here we have 0 if nums 0 target, else -1. Okay, so that's just to get rid of this constraint, to pretend that we have at least 2 values, and now I want to do something. I want to say that I want to find pivot. Pivot initially is going to be equal to 0, and if nums 0 is greater than nums -1, meaning that there is a pivot somewhere, I essentially now know that there is a pivot somewhere, right? So while, let's set low and high to these values, L -1, and while, okay, now let's see, what do I have to do here? While low is less than high, meaning that while these values haven't converged on a single number, let's say low val and high val, they're going to be equal to nums low and nums high, and let's say let's have mid first defined. Mid is going to be low plus high divided by 2, and then we have mid val is equal to just nums. Let's all do this all in one. Mid num nums mid. Sweet. And now we do a simple check. If, okay, now what's the check that we do? We have to figure out if we have to figure out if the mid value is, and what did we say? If mid value is greater than high value, that means that the pivot is in the right section. So if the pivot is in the right section, I say that low is equal to mid. Low is equal to mid what, +1 or just mid? Let's see. I want to converge on, I want to end up with my low or high pointing to a number. So if I'm eliminating yeah, I want this to be equal to mid, else if there's a case that mid value is not greater than high value, then high is equal to mid. And here, do I have to say -1 or no? If mid value is less than, then I say -1. Perfect. Okay, and once I supposedly converge on a value, I would say pivot is equal to low. I have now found my pivot. Let's do a quick test and find if pivot is returning correct number. So for the first example, mid val, what did I say? Mid val. For the first test, I want pivot to be at 0, 1, 2, 3, 4. This one is also 4. I'm getting a mid val at 3, 0, 1, 2, 3. Okay, so something is not adding up. Something's not adding up, and this is so common with these binary searches for me. I always end up having to fine-tune this a bit later. So let's just quickly go through what is the issue. Standard out, by the way, low is just one off. It's one off because possibly of, wait, did I do this correct? If mid val is greater than high val, then I have to say here +1. If mid val is less than high val, there we go. That was a quick, that was a easy catch, I think. Hold on, let me see. Expected for, standard out for. Let's write another quick test. I know I figured out a way to test these situations pretty easy. Let's do 1, 2, 3, and we're looking for a target of 1. This should be equal to 0. Pivot should be equal to 0. Standard out 0. Let's run another test. I have here 3, 2, 1. 1, 2, 3, and let me look at 2, and then have the last one. 1, 2, 3, and have look at 3. Assuming that all of these 3 tests run correctly, then I know that I've configured these conditions here to run correctly. So that's 0. Oh, oops. Okay, so how about this? If it's not sorted, you want this to not be sorted, right? So okay, how about that? If it finds the correct pivot for all 3, we can 2. Wrong. Wrong. It doesn't find the pivot correctly. Oh no, wait. Sorry, it does find the pivot correctly. I'm looking at the target. No wonder. Okay, never mind. It found the pivot correctly. I completely messed up the target with with what a pivot is. So my apologies. Pivot is being found correctly. Now that pivot is found, the next portion of this task is to find the index of the value. So, and here, let's just do a regular binary search. High is equal to now pivot, right? Okay, one sec. Low is equal to pivot. High is equal to pivot plus length of nums, which I have defined as L, and module L, right? High equals pivot plus L module L. Net minus 1. So yeah, if this doesn't make sense, I'm adding a an L to this, meaning that I'm extending the pivot index by the length of the array. And then if this -1 wasn't here, then doing a module L would just result in the same pivot, right? But I want this to be 1 behind me, so this would actually be the correct value. And now while, and now what do I do? While okay, I can't do while low is less than high, right? Or can I do this if I just remove? Can I just do this? While low is less than or equal to high, low val, high val is equal to nums low module L, nums high module L. What this allows us to do is, okay, I'm getting a bit sidetracked. Sorry, that thing came up. Mid is equal to low plus high module, no, divided by 2. No, okay, I'm doing something odd. I'm doing my while loop is looking at a low to be less than or equal to high, which means that my high has to be lower, which means that I can't do module L here. So my high is actually going to be looking at the next, yeah, which is fine. So if I do low plus high, do I have to say here module L? I think so, module L. And so then my nums, my low val, my mid val, and my high val are just low module L, nums mid module L, and high module L. And here, if target is equal to mid val, return the mid, right? L if target is less than mid, val, I set high is equal to mid. Oh, there we go. I don't have to do this. Mid is my mid, and mid, and the way to find mid in the array is mid modulo L. So mid, and then finally else low is equal to mid. Okay, the only thing here is that I have to figure out if I have to add or subtract it. So I always want to, I think I always want to subtract, right? Subtract here because target is less than mid val, so I want it to converge less to a number. And here, low should also be +1. And finally return -1 if nothing is found. Okay. Let's see if this works. Works like a charm. Let's submit this. I'm not completely sure this is gonna work. There are probably some test cases. And yeah, okay, so let's use this test case 3 and 1. Okay, I wonder what the issue is. Is it not finding the correct pivot? Is it doing the binary search after incorrectly? Pivot. Yeah, so this is, I wonder if there's an easy way to do this. Standard out 1. So the pivot is correct. Pivot is correct. I'm doing binary search incorrectly. What am I doing wrong here? Output 2. Oh, mid module L. Hold on, this should work. Awesome. Let's submit it once again. I was returning mid, but mid value is great. Great, that worked. Charm. But okay, I'm getting an incorrect. I'm getting a pretty low run rate. Okay, let's quickly compare to what a better solution could possibly be. Again, in my approach, what I did was, first step, using binary search to find a pivot. Second, use binary search, given the pivot, to find the value. Is there a faster solution? Okay, without even looking in depth, it seems like somehow they were able to couple down finding the pivot and finding the target index in one binary search. So given that information, let's see what this is actually doing. Start and end are equal to the regular things that you set a low and a high to when doing binary search. While this very condition that we also have, mid, very common. If nums mid is equal to target, return mid, given that if you find the mid. And then there's this, and then there's this. If num of mid is greater or equal to nums start, so if mid is greater or equals to nums start, that means that so what does that mean? If nums mid is greater or equal to num start, does that just mean that the left portion of the array is sorted? If the left portion of the array is sorted, the pivot could be at the right. If nums start is less than target. Oh, if target is greater than start and less than or equal to mid, okay, and equals mid minus 1, else start mid plus 1. Hi, it seems like what they're doing here is saying that if num's mid is greater than start, the only thing that's figuring out is if the pivot is in the left or the right portion. So assuming we're into this leg of the for loop, we're actually saying that the pivot is in the right portion of the loop of the array. And if the pivot is in the right portion of the array, we can treat the left. If target is greater than start and less than mid, and has to be equal to mid minus 1. Why is that the case? Because we are saying that I see. What they're saying here is if the pivot is in the right section, then you have, okay, if the pivot is in the right section, you have two options. You have that the number is in the left still or in the right. But the pivot, okay, I see what I can do here. I'm actually just gonna try to recode this with this logic to hopefully get a faster response. So we don't actually need to find the pivot. Turns out that just knowing where the pivot is, in which portion of the array, either the left or the right, is enough to give us insight into where the of how to find the target index. So here we have the same setup, low, high, and let's say that mid is equal to low plus high divided by 2, and what was the approach here? If mid nums mid and it's target, return mid. Oh, start low, low, low. Yeah, running out of time, but so this runs faster. It totally makes sense to me. Yeah, and see, it didn't even run that much faster. So, yeah, I mean, this solution makes total sense. It's first deciding where the pivot is, if it's on the left or the right. If it's on the right, then it's enough for us to check if it's pretty easy for us to check if the target is in the left portion of the array. This just simply checks if the target is in the left portion of the array. If it is, then set high to mid. Else, it has to be in the right portion. So, yeah, it would be pretty difficult to figure out if it's in the right portion of the array because that's where the pivot is. But this just checks the opposite. It checks if it's in the left portion, and similarly goes for the left. All right, so yeah, I don't want to confuse you too much. Both of these solutions are totally valid, and I would probably say that actually mine is more intuitive, but this one does it in faster time. So Yeah, thank you for watching. It's a bit of a long video, but at least it's thorough. So thanks, and see you later. Bye.